In the last video we reached to this point. So if I simplify it, we get, so I will separate these two terms and separate these two terms. So we have psi steric x into iota h bar divided by 2m del square psi, and I will bring these terms here, minus iota h bar over 2m del square psi steric. Okay, and we have x psi, and we have this term minus iota over h bar psi steric into x, because this will get multiplied with this one, and we have v of psi, and here we have this plus iota over h bar v psi steric x psi, and we have this d tau. Now if we look at here, then v is a constant scalar quantity, so we can bring it outside here. If we bring it outside here, then these two terms become equal, so they will cancel each other, and we have this relation, which is integral of psi steric x iota h bar over 2m del square psi minus iota h bar over 2m del square psi into x psi, and we have d tau. If I bring this iota h bar over 2m outside and apply this integral separately to these two factors, we have iota h bar over 2m integral of psi steric x del square psi, and we have d tau minus iota h bar over 2m, and we have this integral del square psi, and we have x psi d tau, which is dx over dt. Let's say this is equation number 4. Now we will simplify this equation. First I will consider the second term, okay? The second term, which is iota h bar over 2m integral of del square psi, and we have x del square psi steric, sorry. Yeah, this is psi steric, because this is this term. Psi steric x psi d tau. And if I apply this integral, then we apply the integral by part. This is a volume integral, okay? So we have two functions, this and this. So we have first function, or we can write it as like we have second function, which is x psi, and then we have integral of the first, which is del square psi steric d tau, okay? And then we have minus integral into differential of the I can consider this is first and this is second. So the first function integral of the second minus integral differential of the first, which is del x psi, into integral of the second, which is del square psi d tau, and we have d tau here. This is integral by part. Now we know that integral and derivative d by dx cancel each other and we got 1. Okay, so it means that from this we got xi, okay, this one, and one integral cancel with one this square, so we have del psi steric minus integral differential of this, which is del xi, and one integral get cancelled with this one, so we have del psi steric, sorry, so this is psi steric and we have d tau. But there are 3 integrals, okay, we have 3 integrals, and these are the volume integrals, so we have 3 integrals. We just apply one integral, so we left 2 integrals. So these are volume integrals, so this 2 integral will be the surface integral, so we have the area and we have dA because this is the surface integral. So our result is iota h bar over 2m and the volume integral of del square psi steric, and we have x psi d tau will be equal to the area integral of this function x psi and del psi steric, okay, dA minus integral of, so there is this terms also on this side, which is iota h bar over 2m, so it will be here also iota h bar over 2m, and we have this one, so we have here iota h bar over 2m and we have this quantity. So it will be del xi into del psi steric and d tau. Now we have a volume, we started from a volume, okay, we can consider a volume like this, and the volume has radius, has 3 components, which is dx, dy and dz, and the limit of the integral are from minus infinity to infinity, minus infinity to infinity, minus infinity to infinity. Now this is a surface integral, so it means that we are calculating the wave function on the surface, okay, somewhere here, which is at infinite distance from the center of this volume, and we know that at x goes to infinity, okay, x goes to infinity, then the wave function goes to 0, because on the surface we don't have the probability of finding the particle will find inside this volume. So on the surface the probability is 0, so it means that the wave function also vanishes. If wave function vanishes on the surface, then this integral will become automatically 0. So we left with minus iota h bar divided by 2m, and we have this integral del psi steric, no, del into x psi into del psi steric into d tau. Now we apply this integral again on this one, integration by part. If we do it, we will use the same procedure again. So we have minus iota h bar over 2m, and we have the first function, which is del x psi del x psi into integral of the second, which is del psi steric. Okay, and then we have minus integral differential of the first, which is del square, because del xi is already there, and we have another differential which is del square x psi. Okay, and we have integral of the second, which is del psi steric d tau, and we have d tau here. Now this will be equal to minus iota h bar over 2m. Again, by using the same procedure which I did here, this will convert to the surface integral. Okay, this is area, and we have del x psi, and we have del psi steric. No, not del psi steric, just psi steric, because this integral and this will cancel each other. And we have minus integral of del square xy, and we have psi steric, and we have data. Again, if x goes to infinity, then the wave function becomes 0 on the surface. So this term will become 0 again, and we have iota h bar over 2m, and the integral is this one, which is del square, and this del square is on this xi, sorry. So we have del square on xi, and we have psi steric, and we have deta. Now using equation 5 in equation 4. Equation 4 is here. Where is equation 4? Yeah, equation 4 is here. Using equation 5, I call it equation 5. So using equation 5 and 4, we have, if we use it here, like instead of this, I will replace this one. This 4 is iota h bar over 2m integral of del square psi steric, and we have x psi deta. If we put it in equation 4, we have dx over dt will be equal to iota h bar over 2m. We have this integral psi steric x del square psi deta, and then we have this plus, no, there is a minus sign, yeah, minus iota h bar over 2m, and we have this integral del square x psi and psi steric deta. This can be written as iota h bar over 2m, iota h bar over 2m is common, so we can bring it outside, and we have integral of psi steric. I will keep it outside, so we have x del square psi, and we have minus del square x psi, and we have deta. I bring this x psi steric and psi steric is also common. I bring it outside. Here we left with del square psi, x into del square psi, yeah. X into del square psi minus del square x psi. So this is another result. Now I will stop here the video, because the length of the video is almost equal to 15 minutes, and I can't upload a video which is longer than 15 minutes on YouTube.